one of the highest markers in exams, period. Differential equations. The first part of this is just to solve as a partial fraction, and this one's particularly easy, especially if you realize that 16 minus 9x squared is just 4 minus 3x times 4 plus 3x. If you solve for the constants by inserting x is equal to 4 over 3 and x is equal to minus 4 over 3, you find that a and b are the exact same values, 1 over 8. Rare occurrence, but nice nonetheless. The next part gives you some context about the container, its dimensions, and more specifically the rates at which the volume increases and at which decreases because it has a hole inside. When writing the rate of change, you need to consider water going in and water going out. That's going to be your overall rate of change. So the water going in will be the 0.16 cubic meters, and the water going out is 0.36 d squared, where d is the depth of the water. Remember that information. This is why the 0.36 d squared is a minus, because it's water going out. But the problem says to show this in terms of v, but you only have it in terms of d, so what exactly can you do? Well, read the question. It says that at t minutes after the container starts to be filled, the volume of water is v, meaning that you can generate an equation for the volume of water inside the cube by multiplying the surface area by the depth, because that is the equation of volume, cross-sectional area, times length. The reason that's important is you can make that equal to v and make v the subject afterwards. So d is going to be equal to v over 2. Inserting that back into the original formula gives me 0.16 minus 0.09 d squared, which is the same as 16 minus 9d squared all over 100. Next, find t in terms of v. All you need to recognize is that the expression you just generated is identical to your first partial fraction. So put the 16 minus 9v squared to the dv side, the dt put it into the other side with the 1 over 100, and then you can turn 1 divided by 16 minus 9v squared into 1 over 8 times 4 plus 3x plus 1 over 8 times 4 minus 3x, and all of that is 1 over 100 dt. I'd recommend keeping the 1 over 8 outside the integral like I showed here. It makes it less messy. Solving it gives you 1 over 24 ln 4 plus 3v minus 1 over 24 ln 4 minus 3b is equal to t over 100 plus c. You then need to find the constant c, and for this you just say that at t is equal to 0, the volume of water inside is equal to 0. So of course, this makes the c constant 0. Determine how long it takes to fill the container. This effectively means finding the time at which v is the volume of the cuboid. And the volume of the cuboid is 1.25 times 1.6 times 0.5, which is just 1. So insert v is equal to 1 and rearrange for t to get 8.108 minutes. I was supposed to give it to the nearest 8 minutes, but I guess I didn't realize at the time. A bit of a spicy one, but again, manageable.